Let us look at proposition number 57 of book 10 of Euclid's Elements. The proposition says, if an area is contained by a rational straight line and the fourth binomial, then the side of the area is the irrational straight line called major. Okay, let's see by trying to find the straight line, a major straight line, and we will understand what this proposition is talking about. So we are given an area AC contained by a rational straight line AB and a fourth binomial line AD. Divide AD into its terms at E. Then AE and ED are rational straight lines commensurable in square only. Remember, AD is a fourth binomial line. We are dividing AD into its terms at E such a way that AE is greater than ED. So what that means is AE and ED are rational straight lines commensurable in square only. And AE square is greater than ED square by the square on a straight line incommensurable with AE. These are all part of the definition of the fourth binomial. AE is commensurable in length with AB set out. And now we bisect ED at F to AE, a parallelogram AG by GE equal to the square on EF. Let's apply, or let's find a point between A and E such that AG by GE is equal to EF square. So let's find that. Now AG is incommensurable with GE, or GH EK FL from GEF parallel to either AB or CD. So let's draw those lines. Now construct SN is equal to AH. Okay, let me first name these points as well. We have to name it as H, K, and L. H, K, and L. So we have to construct SN, a square whose area is equal to AH. Now construct NQ is equal to the area of GK. So we have to draw another square NQ whose area is equal to GK. And we will draw it at this point. Let's name this as RQ. So NQ is equal to GK. Now we complete the parallelogram SQ. We complete this parallelogram. So which means we have to complete this rectangle and we have to complete this rectangle. So let's do that. Now, which means we have seen a lemma where we have proved this, that SQ will also be a square. AG by GE is equal to EF square. Then which means AG is to EF is equal to EF is to GE. That means EF is the mean proportional between AG and GE, which means the figures on them will also be in the same proportion. AH, which is the figure on AG, EL, which is the figure on EF, again EL, figure on EF, and GK, which is the figure on GE, which means EL is a mean proportional between AH and GK. Remember, AH is equal to SN and GK is equal to NQ. So which means EL is a mean proportional between SN and NQ. Now, based on the lemma, we also know that MR is a mean proportional between S and N in Q. So which means EL is equal to MR, and we also know that this rectangle is going to be equal to this rectangle. So that means EL equal to MR equal to PO. AH plus GK, AH plus GK is equal to SN plus NQ, because AH is equal to SN and GK is equal to NQ. These two rectangles are equal, and these two are also equal because this is F is the midpoint of ED. So this is equal to the sum of these two rectangles. So which means AC, the complete rectangle here, is equal to SQ, the square, the complete square. That SQ can also be written as MO square. Why? Because MO is equal to SJ. So we can say the square on SJ, or we can also say square on MO. MO is the side of a square whose area is equal to the area of AC. That is what this MO is the side of AC means. Now, AG is incommensurable with GE. AH is incommensurable with GK, and so is SN with NQ. So, which means M and NO are incommensurable in square. SN is incommensurable with NQ, SN incommensurable with NQ, SN is a square on MN, and NQ is the square on NO. So if Sn is incommensurable with NQ, Mn will be also incommensurable with NO in square. Now, AE is commensurable with AB. AE is commensurable in length with AB set out, which means the area contained by AE and AB is going to be rational. And that area we can refer to as AK. AK is equal to AH plus GK, which is equal to SN plus NQ, which is equal to MN square plus NO square. So MN square plus NO square is also rational. Okay. DE is incommensurable with EK, which is actually equal to AB. So we can say DE is incommensurable with AB. Now DE is commensurable with EF. Why? Because DE is a multiple of EF, because F is the midpoint. EF is incommensurable with EK. So which means EK and EF are rational straight lines commensurable in square only, which means EL is the area contained by EK and EF, that is EL, is medial, which means MR is medial. Why? Because EL is equal to MR. MR is contained by MN and NR. But NR is equal to NO because this is a square. So we can say MR is contained by MN and NO. That means MN by NO is medial, since MR is medial. MN plus NO is equal to MO. So that means MO is a major straight line. Now, how can we say it is a major? Because we have shown that MO, its terms, which are Mn and NO, are incommensurable in square. Mn square plus NO square is rational, and Mn by NO is medial. So we can say MO is a major. So that is proposition number 57 of book 10 of Euclid's. elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail with the references to the appropriate previous propositions and lemmas and corollaries. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.